Let's do a few practice problems with transcendental functions. And in case no one ever told you what a transcendental function is, it's basically a function like log or sine or some other trig stuff. There are things that involve solutions that cannot be solved with regular algebra. It's a different type of operation. That's the very fundamental generic answer for what a transcendental function is. Now you know. Let's jump in. Okay, let's find the derivative of 4x log x. And I want to point out that the base of our log is an understood 10. I also want to point out that this is 4x times log x. So we're going to do the product rule. I am going to write my f's and g's, f primes and g primes, because we have some new stuff to work our way through. So f is 4x, g is log base 10 of x, and f prime is, no surprise, g prime is the derivative of log. Okay, so that's going to be 1 over x. There's a little bit more on this one. Because it's not a natural log, we need to throw in to the denominator. We need to multiply by the natural log of that base. So natural log of 10 times x. That's what we're really dealing with right there. So as we go through f prime g plus f g prime, we'll have a little bit of a mess. We'll clean a few things up. It really won't turn out to be too bad. So here goes. Final answer. We'll just go ahead and call it y prime. F prime g 4 log x plus f g prime. Okay, I hope you notice what's about to happen. I'm about to erase this and start the next problem. I'm kidding. What I am going to do is cancel out this x with this x, and I'll simplify just a little bit. So we're going to basically have a constant over here. This is going to be 4 over natural log of 10, which is not a pretty constant, not a rational constant, but it is a constant nonetheless. So we're going to have 4 log of x plus 4 over 1 times 1 over ln 10, so 4 over natural log of 10. And that is what we're going to have on the first one. Let's go through a couple more. The next problem is 4 to the x times tangent of x. So I'm going to erase this. Pause it if you need to. So we have 4 to the x times tangent of x. And just to be a little more consistent with the way it shows up on the paper, this is really f of x. But again, let's not confuse f, the problem itself, with the f's and the g's that we use to work through a formula. Okay, so as I write f and g, that is not to be confused with this f. You've heard that before, but I just want to make sure we're clear on that. So multiplying 4 to the x times tan x, so we have 4 to the x, and we have tan x. The derivative of tan is secant squared. Good guess, good guess. The derivative of 4 to the x is, okay, well, let's think about this again for a second. The derivative of e to the x is e to the x. So the derivative of 4 to the x is 4 to the x, but there's more. That's why I left the gap in the front. We also have to multiply by the natural log of that base itself. It's one of the things that we do. Long list of reasons for that, but in the meantime, we'll just stick with that. Product rule. Two things are multiplied together, so let's just jump to the final answer and simplify if necessary. Final answer will be f prime, and I mean f prime, original problem, not to be confused with that. So f prime g plus f g prime, so natural log of 4, there's your constant, your coefficient, 4 to the x times tangent of x plus f g prime. And this is totally correct. I'd accept it. You'd accept it. We're happy. It's great. It works. On a multiple choice question, this may not be the answer, so I'm just looking at ways I could simplify this a little bit more, and I noticed that both terms have 4 to the x that can factor out. So if you wanted to, you don't have to, you could go a little further and say this is really 4 to the x times natural log of 4 tan x plus secant squared, basically just factoring out that 4 to the x. Okay, let's do one more. And the next one is not going to be too painful. It's going to be pretty straightforward, so I'm going to erase this. Feel free to pause and copy if you need to. And the next one is g of x equals 4e to the x cotan of x. All right, g of x equals 4e to the x cotangent of x. And again, product rule. We're dealing with two things that are multiplied together. Didn't do any quotient rule on these. Just a bunch of product rules. And I think it's fairly obvious what we have going on here. f is 4e to the x. The derivative of 4e to the x is 4e to the x, because the derivative of e to the x is e to the x, but you just multiply it by 4. So it's 4e to the x. It's just a scalar. So g is cotangent of x. The derivative of co is going to be negative something. The derivative of cotangent is negative. All right. Tangent is secant squared. Cotangent is negative cosecant squared. There we go. And let's do the product rule on this thing and just jump straight to the final answer and clean up if necessary. So we have g prime, again, that is this g prime, not that one. F prime g plus f g prime. Totally correct. I'm happy. You're happy. Let's keep going though. I notice an e to the x, 4e to the x actually, that cancels out. So 4e to the x. And let's clean up the fact that this negative's floating in the middle of the term. That's just awkward. So cotangent of x minus cosecant squared of x. And there we go. That's what we have. And that finishes that problem.